Alright, today we're going to continue modeling some more, building on what we've done already, and making sure we understand the strategies, how to write expressions, equations, how to solve, all that fun stuff. So the first thing is percent change. The percent change formula is in your unit packet, where you see it is the absolute value of the original minus the new value, all divided by the original, and then multiply it by 100 to make it a percent. So if you are told that cable TV cost $7.69 per month in 1980 and $30.08 per month in 2000, find the percent change. So I want you to try this on your own. Use that equation. Pause the video. Unpause when you're ready to check your work. Okay, so hopefully you got that it was a 291.16% increase. So how do we do that? Well, here's our setup. Plugging into the percent change equation, 7.69 minus 30.08, the absolute value of that is 22.39, divided by 7.69 and multiply by 100, and I get 291.16. When we're talking about percent change, you should always get a positive value because we're using the absolute value, so you should always have some sort of word in there to indicate was it an increase or was it a decrease, because your percent change could be a decrease as well. So keep that in mind, that you make sure you're answering the question so that it makes sense to a reader. Next one. So a picture frame has a total perimeter of 2 meters. The height of the frame is 0.62 times its width. Draw a diagram that represents the problem and identify the width as W and the height as H. Then for part B, write H in terms of W and write an equation for the perimeter in terms of W. And then for part C, find the dimension of the picture frame. Alright, so I want you to try to do these on your own. At this point, we've done enough examples together over the past few days, so you should be able to at least come up with the picture and hopefully the equation, and once you have the equation, you should be able to solve it. If you get stuck at one of those steps, then just unpause the video and check your work along the way. So go ahead and pause now and solve. Alright, so I'm going to go through this one step at a time in case you get stuck at a certain step, but figure out the rest. So if I draw a picture, that would be my picture frame. Here's the width, here's the height. I know the perimeter equals 2, which is 2 times W plus 2 times H, because that's what perimeter is. Alright, so writing H in terms of W, I know H equals 0.62 times W. And since the perimeter is 2W plus 2H, I know it's 2W plus 2 times the quantity, 0.62W. If I simplify this and combine like terms, I get that the perimeter is 3.24W. So then the dimensions of the picture frame are going to be the width is 0.617 meters and the height is 0.383 meters. And I got that by using my perimeter equation here. Then I know the perimeter is 2, so I said 2 equals 3.24W, divide 2 by 3.24, and I end up with W. Then remember, again, make sure you're answering the question. The question says find the dimension of the picture frame. So you want to know both the width and the height. It doesn't say just find the width, and it doesn't say just find the height. Make sure you include units as well. Next one. 2 cars start at an interstate interchange and travel in the same direction at average speeds of 40 miles per hour and 55 miles per hour. How much time must elapse before the 2 cars are 5 miles apart? So this one's going to be a little bit more work. You are going to need to use your relationship between distance, rate, and time, which we talked about on the previous video and is also on your unit packet. But just to refresh your memory, distance equals rate times time. So I want you to try this on your own. I realize this one's a little bit more difficult, but try it on your own. Do the best you can. See if you can solve the problem. If you get stuck anywhere along the line, unpause the video and see if you can follow the solution. Okay, if you have absolutely no idea where to start, I would start by writing one equation for the first car and one equation for the second car. It doesn't matter which one you call D1 and D2, as long as you note that the distances are different, so I have to call them d1 and d2. However, notice the time is the same, because both of them have been traveling for the same time, so I can call that just t. I don't have to call it t1 and t2, but within that time they are going to go different distances because they have different rates. So this is where I would start. So if that helps, go ahead and continue to work the problem. If you're not sure, then just listen to more explanation. Alright, next piece of information we want to recognize is that I want to find when the distance between the cars is 5. So since I know that the second car here, what I'm calling the second car, is going to be, since it's going faster, it's going to be further than the first car. So I want to do d2 minus d1, because that's going to make it a positive value since this is going to be a larger distance. And I know that d2 minus d1 is 5. Had I switched these around, then I would do d1 minus d2. Okay, if that helps you, then pause and continue to solve. If you're still stuck, keep it unpaused and listen to more explanation. Okay, so then I continue on. Since I know d2 minus d1 is 5, I know 55t minus 40t is 5, since d2 equals 55t and d1 is 40t. So I can subtract those since the t is the same variable, and I get 15t equals 5. Therefore, t is 1/3 of an hour. So it'll take 1/3 of an hour for the cars to be 5 miles apart. I could also say that that's 20 minutes, because 1/3 of an hour is 20 minutes. So either of those would be correct. Again, it's very important that you use units, though, so somebody understands that it's 1/3 of an hour, not 1/3 of a minute, or 20 minutes, not 20 hours. Next one is a mixture problem. So a forester mixes gasoline and oil to make 2 gallons of mixture for his 2-cycle chainsaw engine. This mixture is 32 parts gasoline and 1 part 2-cycle oil. How much gasoline must be added to bring the mixture to 40 parts gasoline and 1 part oil? So this is going to be a system of equations again. I want you to pause the video, try to come up with the equations and solve. But again, if you get stuck at any part or at the very beginning, unpause and follow along to the solution. Okay, so this one's kind of tricky. We need to recognize that we have units of gallons, and we want our answer to be in units of gallons. However, we also have units of parts. And parts is kind of, it's a little confusing to deal with, but we're going to have to deal with it. So the first thing I did was I defined a variable. So I said x is the gallons of gas that we are going to add to our current mixture. Remember, our current mixture is 2 gallons. Our final mixture, we don't know how many gallons it's going to be. It's going to be more than 2 gallons. It's going to actually be 2 plus whatever x is. So how do I set this up? Well, I know I want to get 40 parts out of 41. Because I'm going to have 41 total parts since I have 40 parts gasoline and 1 part oil. So I want 40 out of 41 to be gas. So since I originally start out with 32 out of 33 being gas, if I multiply that by 2 gallons, that will give me how many actual gallons of gas I originally started out with. Now I'm going to add some X amount of gallons of gas. I need to divide this quantity by 2, the total amount of gallons, plus this X as well. This is going to eliminate the gallons as a unit right here, and to allow me to work in parts, since that's what this side of the equation is. So now that I have my equation, I want you to go ahead and solve if you haven't already. So pause the video again. Solve the equation for x, unpause when you're ready to check. Okay, so we should end up with 0.485 gallons. So again, going back to this original equation, I multiplied both sides of the equation by the least common denominator, which is 41 times 2 plus x. So the left-hand side now becomes 41 times 64 over 33 plus x, because 32 times 2 is 64. And then the right side of the equation becomes 40 times 2 plus x. Distribute, combine like terms, and then type it into my calculator in the end, and I get 0.485 gallons. So that's how much gas I need to add to the original 2 gallons in order to change it from 32 parts gasoline to 40 parts gasoline. Last one. Should be a little more straightforward. Solve for R in the given simple interest equation. Pause the video, solve for R, unpause when you're ready to check your answer. Okay, so depending on which order of operations which order you went about doing this, you are going to end up with either A minus P all divided by PT equals R, or A over PT minus 1 over T equals R. Either are correct. They are the same exact thing. What I did was I subtracted this P first and then divided by PT. That's how I ended up with this. But had you factored out a P first, you would end up with this version. But again, they are the same thing. Okay, that's modeling.